So we just completed 2 demo classes. This is the third demo and final demo class. So since you are not aware, so I'll just give you a brief introduction what we have discussed in the past 2 classes.
Sure.
Yeah. So the prerequisite for this design pattern course is to have the core Java knowledge. That's a mandatory. If you have core Java, then you can join.
Yeah.
And in this class, we are going to discuss about the design patterns. So the design patterns are divided into different one: creational, structural, behavioral, and then microservice. So under the creational, these are the things that we are going to discuss. Under structural, these are the things. And under behavioral, we are going to discuss about this. So we are also going to discuss about the microservice design patterns. So in the first class, I was talking about what is the need for a design patterns and what is the importance, what are the advantages, why do you need to learn the design pattern. I have already spoken about in the first class. If I have to repeat, that becomes entire 1 hour. So today, after the class, you are going to get an email from the Ashok IT. So that email will have the link of the class, like YouTube video will be provided. You can watch that. And yesterday we started with a singleton design pattern, and we have written a program on how can I make the class as a singleton. That means even if you call 100 times, it should give only one object. So that we made the singleton design pattern yesterday. Now coming to the duration of the course and fee. So the fee is 5,000 rupees, and the recordings will be provided up to 6 months without, we are not charging anything for the recordings. And the class is every day morning 9 a.m. to 10 a.m. Monday to Friday. The duration is we'll complete within 45 days. And we are at the end of the course, we are also going to see overview of solid design principles.
Okay.
Any questions?
Yeah. Sir, whatever it is there you explain. So can you explain using the UML diagrams, sir, before starting any design pattern with examples?
Okay.
UML
so
design.
Yes, UML diagram will just contain the class name, method name, how it is going, correct?
Yeah,
so
yeah.
I'm writing the code from scratch itself.
Right.
Yeah. So that is good than the UML diagram. If it's a UML diagram, generally what used to happen is that becomes a design, correct?
Yeah,
so
structure.
So maximum whenever in your project, if you are creating a new method in a class, you will mention the class name from this class. You will create a arrow mark. You're going to this method and getting a return type and all. But while discussion of all of those, we are writing itself. See, why am I writing that method? All those things I am explaining while writing the code itself. That UML diagram will be good if the code is already present, if I am explaining the code, correct? So, but I am writing the code from scratch itself. So it would be like whatever I'm explaining, it's good than the UML diagram.
So suppose if you give the basic idea before starting of that one, by showing the UML diagrams, we'll come to know what you are going to do. Then if you go inside, then it will be easy for us to understand. That's what I'm asking. Just a skeleton overview only. Just diagram.
Sure. Yeah,
that will print on our mind what you are going to do. Otherwise, that we will be on thinking what classes will be generating, what classes you are going to create, what you are going to do. That will be in a blind thing.
Yeah, sure. I'll do that as well.
Yeah, please do that one. That will be helpful for us also to show interest. What we can plan, like what we can like interactively, speak with you.
Yeah, sure. Yeah. Anything else? Anyone?
Hello.
Yeah.
Sir, actually, I haven't gone through the demo of yesterday. Are we going to cover a proxy design pattern in this?
Yeah, it's already there.
Yeah, okay. I haven't seen the previous lecture, so that's why.
All the creational, structural, behavioral, its proxy is part of the structure itself. It's there.
Yeah, okay, sir.
Okay. For all these design patterns, we will write a program, guys. And see, no one can implement all these design patterns in a single project, guys. It is not for me. No one can. It is not possible, because design pattern, just like that, you don't implement. If there is a business need and if there is a problem, then you go, correct? So similarly, whenever we are discussing any pattern, where this can be used in your project, what is the best advantage? So that kind of examples also I'll be explaining. while discussion of the corresponding design pattern. Any questions on the content or course fee, etc.? Anyone?
Sir,
What are the other microservices design patterns we are going to cover? You told
Yes.
that only two more you are going to.
Yes,
Have
yes,
you
we are
finalized?
going to. Yeah, I did not add it here. I will add it.
At least may I know what are those two? Have you finalized those two?
No, it is not yet finalized. So I'll let you know.
Sir, one more clarification, sir. Is it cover J2W design patterns? Sir?
No, it will not.
Oh,
Only
okay.
these
Is
are
it
the things.
okay? Is it a need or it is in other course, sir?
It is not mandatory J2EE. See, J2 when your dispatch, see, J2EE patterns are nothing but if you know the advanced Java and Spring Boot, automatically J2EE will be covered. You don't need to study separately.
Oh, okay. Sir,
if you are having a good knowledge of the Spring Boot and then advanced Java, then that itself will cover the J2EE patterns. Why do we go for J2EE? To create an enterprise application, correct?
Yes, sir.
J2EE means Java to Enterprise Edition, correct? So
Okay.
if you know the how do we create an enterprise application? By using the framework. Enterprise application is nothing but it can be a web application or ER, correct?
Yeah.
So
That
whenever you're
framework-
creating a web application, you are using a framework. Whenever you're using a framework, obviously you are using a J2EE patterns only.
Yeah. It is a framework itself. It is following the patterns.
Yes, So you might be knowing that, but you don't know the terminology. You just look at the terminology; it will be helpful.
Okay.
But
Is
that
it
will not be covered. That will not be covered here.
Okay. Is it microservices design patterns? Is it part of J2W pattern or
No,
separate?
no. Microservice is different.
Okay, sir.
Sir, as per the current market situations, are we covering the present design patterns, all whatever the market is required?
So
Right.
that is what it is mentioned, right? In the market nowadays, they are asking say singleton strategy, prototype, builder, and then adapter, interpreter. These are the things that will be asked in the market maximum in the interviews. That will be covered under this 23. See, if you look at structural, creational, behavioral, I have not missed anything, guys. There are 22, I think. Entire 22 we are going to discuss. And in the microservices, we are going to discuss the top 8. I have mentioned 6, remaining 2 will be added.
Okay.
Sir, actually, this microservices design patterns, are we going to cover any mini project regarding?
Yes. So when I have to explain, for example, you have seen API gateway or distributed tracing or database per service. So we are going to create some sample microservices. We'll take some use case.
Okay.
And then if I have to explain the API gateway is nothing but like you will, one first microservice will receive all the requests and then it will route it to the corresponding microservices. How it has to do, it is not a theory. I will take some use case. From that use case, we will build 2 or 3 microservices and then we'll see how it will happen with API gateway, without API gateway. That is how we'll see.
Okay, sir.
We'll see, we will create microservices. When I say microservices, the small use case, it is not like a big project. Okay. Yes, to answer your question, yes, we will create microservice, multiple microservices. And then if I have to explain distributed tracing, what is a distributed tracing means? Assume that you have an application. In your application, there are 10 microservices. So now the 10 microservices names are A, B, C, D, E, F, G, H. Now from A, you have gone the request to the B. From B, it will go to C, C, D, D, E, E, F. And these services are developed by different teams. Now, someone is telling that this use case is not working. Now, how can you tell that where it is breaking? Is it breaking in service A, or is it breaking in service B, or is it breaking in service C? How do you know? Correct? If it is a monolithic application, you can see the log. Am I right?
Yes.
Directly, it will give you the class name, method name, everything. Okay. But it's a microservice application. How do you know whether your service has received the request or not? Correct? Whether it is received, whether it has provided an output or not. Correct? Yeah.
Yes, sir.
So in order to do that, we use a distributed tracing. So how we are doing the distributed tracing? We will create around 2 to 3 microservices, and we'll add the distributed logging like sleuth and another dependency, Zipkin and sleuth dependency. We will add it, and then we will see how we can trace a request that is traversing over a like when you have given a request to one microservice, after A to B it has to go, whether it has gone or not. B to C it has to go, whether it has gone or not. That will be taken care by the distributed tracing. So in order to explain that, I'll be creating multiple microservices, and then we will see how it is happening. We'll create live coding itself. When I say microservice, it is not like I have created at my home, and then I will show you the code. No, we'll create a microservice from scratch.
Okay, sir.
Can you guys tell me how much time does the Spring Boot application will take to create?
Hardly 5 minutes or 10 minutes.
Yeah. And then we need to, so once you create that, it will give you the skeleton. And based on our use case, we will write the coding, correct? And then we will see how, see, in order to explain the distributed tracing, do I need to create an application, a real-time application? We need to know the real-time use case, correct? And say, for example, if I'm triggering an email, are you mainly focusing on a triggering an email, or how, whether the email, see, sending a request is one service, triggering the email is another service, and providing the response is another service. Now, we are interested in whether the request is gone to these 3 services or not, or where it is failed. In order to do that, do I need to create an email notification code, or do I need to concentrate more on the how the request is traversing?
Notification.
Yeah. So the design pattern is talks about the distributed tracing means whenever the request is coming to the service, how can you say that for this corresponding request, this service, this microservice has what you call successfully executed, and there is no problem this one. And from this one, this is the output it got, and the request went to the second service, right? So that is what we will be focusing more. Any questions?
Yeah, sir.
Are you going to use any tools to implement these microservices?
What tools?
Suppose
What do you mean by tool?
If you are to, for example, take a message queue like that.
Whenever it is needed, might use a Kafka.
Yeah.
Yeah. It is not needed for all the services. For some things it's needed. So at that time we might use a Kafka.
Okay.
Sir, I don't know about the microservices. Still, the course content is going on. So,
okay.
So should I learn the microservices before that one, or is it okay?
Yes. I'll try to create a microservices. That time you can know, but I am not going to explain how to design a microservice. Like if I have to do a microservice, I will tell you the steps, and I will create on scratch in front of you in the live class. So with that, you need to know. Okay. But in the microservice, if I have to do the REST template or Fiend client and all, that will not be part of the course, because that becomes a microservice, like Spring Boot and microservices course is going on, right? That is a part. Yeah, exactly. That is a part.
By that time, I think it will be complete.
Yeah.
By that time.
Yeah.
We hope. Right.
So whenever I'm discussing, if you ask me a question, I can explain, but I cannot explain how to create a microservice and all, because that becomes a Spring Boot and microservice course, not the design pattern course.
Okay. Okay.
Yeah. Anything else? Anyone? Any questions? Yeah. So today will be the last demo class, guys. So if you are interested, before tomorrow, you please enroll it. Now, all of you, did you guys have received an email? Some of you said yesterday you haven't received any email.
Yes, sir.
I received that email.
I could not get. And the amount also modified, correct?
Yes, Karthik, modified.
Yeah, fine. Okay, if you are interested, you can do the enrollment. Let us continue with the singleton pattern. So in the last class, we have created a singleton design pattern. So let me show you guys the code. So in the last class, we created a class called singleton design pattern. And can someone tell me what is eager initialization?
The object is
Sliced
created.
while creating object in class loader at the time
Okay.
of class loader.
Okay. What else? Anyone? Others?
This is a creation of object even before attempting to use that class in a program.
Yeah.
That
So
means
before
at loading
calling
time
the
of the class.
before calling the get instance method itself, you're trying to create a object at global level, like at class level, correct? So that means where this will be loaded during the class load time. So the disadvantage of this eager initialization is even you have created a class and you're not using a get instance method, but still the object is creating. So that's the problem. Now, in order to overcome this, in order to overcome the problem of eager initialization, what do we do?
Go for lazy initialization.
Yeah, we go for lazy initialization. In lazy initialization, we'll initialize the variable to null. And whenever the get instance method is called, we will create an object. And in this way, at any number of times you call the get instance method, it will return you the single instance. So yesterday we have seen I'm calling 3 times, but 3 times the hash code is same. Now I can say that, can I say that this code is behaving like a singleton design pattern now? Yes or no? Yeah. Now let us see. Yeah, let us see. Now, so now we can break the singleton design pattern with a different techniques. What are those techniques? See, multi-threading, serialization, cloning, and reflection. Now let us see the serialization. So serialization is nothing but it's a process of converting the object into a series of bytes. This is a core Java topic. So in order to do the serialization, first your class should implement serializable interface, correct?
Yes.
Yeah. And then we need to serialize the object. How do we do the serialize object? Object output stream you can use. And then inside that object output stream, there is a method called write object. This method is responsible to the serialization. And in order to do the deserialization, we need to use a read object. Okay. These two methods, write object is responsible to create a serialization. Read object is responsible to create a deserialization. Okay. Now, I will write a code of serialization and deserialization, and I will show you guys whether it is breaking the singleton design pattern or not. Okay. And then we will fix it. Now, so the serialization is nothing but writing the object or converting the object into a series of bytes and writing the series of bytes into a sending over a network. In order to over a network, let me write it to the file output stream. File output stream f equal to new file output stream. Okay, done. Now let me give some location. So let me take this and let me delete this. Okay. So let me go to the desktop. See users del desktop and copy this path automatically. So what I'm doing, guys, here. So I created a file. So I want to create this file instance, and then using the object output stream obj equal to new object output stream, and then it takes, and then obj dot write object, and then I will pass s. Now let's add a, yeah. Okay, now if you look at this code, now what this code will do is, see, object output stream is, this is a class which is responsible to convert the object into a series of bytes. Which method will do that one? Exactly this write object method present in the object output stream class will convert the object into a series of bytes. And then I am writing that output into this file. Now, currently on my desktop, there is no file called serialization.txt, serializable doc. Okay. Now what? Let's run this program and see what happens. See, I am getting an error. Look at here. Not serializable exception. So the first step we missed it. So whichever the class you want to serialize, what you need to do, you need to implement a serializable interface. So let's add implement serializable. Done. Now let us run the code now. Run as Java application. See, it's done. No issues. So it should have created a because since I'm writing the object state, the series of bytes, whatever the right object is converting the object into a series of bytes. Where did I write that? That output I'm writing into this of this location. Now let us go and see here. This is the document it had created. See, do you understand what is there inside this?
No.
No. So that means what these 3 lines of code has done. So there is a what is this S? Can I say it's an object?
Yes.
Now this object is converted into a series of bytes by write object method. And then that series of bytes is written to the document. Done. Now, if I want, so now I will give, what I will do is I will give this file to my friend. Will he be able to understand?
No.
Now, but what is there inside this object? He wants to read it. Then what he has to do? He has to write a deserialization program, correct?
Right.
So in order to write a deserialization, what is the first thing that he has to do?
Yeah, file input stream.
That means he has to understand what is there inside the file, correct? He has to read the file, correct? Now, file input stream. F1 equal to new file input stream. Since I'm doing both in my place, so I'm giving the same location, correct? If my friend is keeping in a separate location, he can give the different location. Done. Now, after that file input stream, then you need to use an object input stream. Object output stream is responsible to create a serialization. Object input stream is responsible to create deserialization. Object input stream, let me keep F1, done. Now, which method will do the deserialization? Read object. What this read object will do? Whatever the, see from this document, in this document, what does it contain, guys? What does this document contains?
Object.
Yeah, object state, correct? And it is converted the object state into a series of bytes. It is present, but as a human being, I'm not able to read it. But who can read that? This read object method is efficient to read this and construct the original object back. Okay. Now, what does it mean is, like, let us take, now here in this class, let me have one variable called string s equal to Karthik or string name. Okay. Now, whenever I create an object for this one, can I say that for this name variable, memory will be allocated?
Yes.
Okay. Now, let us comment this line. For time being, let us run the program again. Let me remove, done. So when I run the program, the serialization is done. When I say serialization is done, can I say that your S object is serialized? Okay. What is the, see, whenever you are creating S object, so can I say that it will occupy the memory for this name variable also, since it is an instance variable? Yes. So that means the object is containing the name as Karthik. But do you understand by looking at this, like this doc? Can you understand what is the value of a name variable?
No.
It is something, correct? Now,
Yes.
that means it is converted into a series of bytes. Now, how can I do that? Look at here. You need to write a read object. In.read object. Okay. It will give you the object. What is the object? It will give you singleton design pattern object. Let's keep it here. And then S1. And then let me do the typecasting. Done. Let me, instead of S1 is already there, let me keep S4. Now, yeah, let me add sysout S4 dot, what is the variable name? Name. Now let me try, right click, run as Java application and print it. Run as Java application. See, am I able to construct the Karthik back? Yes or no? Hope you understand, guys. This is about a serialization, and then this is about a deserialization. Now the thing is, can I say that in the line number 37, the read object has given me the new object. I mean, like it has given me some object called S4. Now let me print the hash code for this one, S code. S4 dot hash code. If I try to print, if the hash code is C, we have the hash code of S1, S2. These three are same object because the hash code is same. Now let us see what is the hash code for this one. And if it is different, can I say that it has created a new object? Or different, same object?
Different object.
That means for one class, singleton design pattern class, am I able to create multiple objects using the deserialization?
Yes.
Oh, that means am I breaking the singleton design pattern with the concept of deserialization?
Yes.
Yes.
I hope everyone understood it. Did I prove that?
Yes.
Yeah.
Yes.
Okay. Now let's fix this one. Now, in order to fix this one, what you need to do, you need to write. So whenever the read object method is getting called, internally it will call one method called read resolve. It will call read resolve method. The read resolve method is responsible to create a new object. Then what I will do, I will override the read resolve method. Let's write read resolve. This method will return object. Now what I will do, return S. I will return the S object, whatever it is present. I don't want to create a new one. I will create a return. If I don't write it, by default implementation will happen, correct? But what I'm doing, I'm overriding this method and returning the object that is S already present. Okay. Now let us run the program and see the hash code. Run as Java application. So do you see the same hash code or different hash code now?
Same.
That means how many objects are getting created?
One object.
So that means even if you do the deserialization, is it creating a new object?
No.
So that means I have fixed the problem of a deserialization, correct?
Yes.
Any questions, anyone?
So Karthik, in this case, let's say we are moving that object to some other JVM.
Okay.
Will this, in this scenario, still will get the object in other JVMs? Or
yeah, whenever you are using a different JVM, you need to use a database concept. Like whenever you are instantiating a JVM, so this memory, when this memory gets allocated, at this point of time, it's a standalone application, correct? So if it is a Spring Boot, the object will be created per container. But here, whenever you run a program, the JVM will be instantiated. And if you run the same program again in a different instance, one more instance, correct? It will create another object. But if you want to limit that, what you can do is you have to use a database. And whenever you are creating an object, send a record into the database. And next time, whenever another instance is running, if that already one more instance is running, then you cannot start that program itself. In that way, you can limit it.
No, my question is, let's say we created the file, right? This serializable doc.
Yeah.
If I import the serializable doc manually to other instance.
Yeah.
And assume that I have the class in that other instance. Same class. Now
okay.
I try to deserialize in that other instance.
Okay.
So will it give error or it will give an object?
When you say other instance, do you have the same program here, singleton pattern?
This class I created that manually there in other instance.
Okay.
And this manually I moved this file which is accessible to the other instance. And use that path and I deserialize it there in the other instance.
Yeah. It will give you a new object because in that other instance, you do not have the read resolve method.
Okay, but I will not get an error, right?
Yeah, no. Because during the deserialization, you don't get an error. Unless until, see, so here now, let me modify this file. Okay. Now let me deserialize. Let me comment this one. I don't want to serialize again. I just wanted to do the deserialization. Now I will get error because I have modified it, correct?
If you modify it, obviously it will ruin that file and it will not be in a position to deserialize it.
Yes.
If we don't modify it and if we try to deserialize, because this read resolve is trying to return the static
Yes.
object. Right?
Yes, yes.
Whatever
is the object is present,
follow
it
the
is
same approach, I think, because that is not available, it will create a new. Okay.
Yes, so it will create a new object. If it is available, it will give you the same object.
So as long as it's available in the instance, it will give the same instance. Otherwise, it will give a new instance. Okay.
Yes. Yeah. Okay. Now, let us see the next topic. The other thing is interesting, the multi-threading. So now I will break this design pattern using multi-threading. Now, what is meaning? What is meant by a multi-threading? I need to create a thread, correct? I can use the executor framework or create a thread. Now, can you guys tell me how can I create a thread in Java?
Yeah, you can using thread class and implementation of runnable interface.
Now I am doing extends thread. Okay. Now let me. So whenever I'm extending a thread class, I'm creating a main method. Okay. Now thread1 t1 equal to new thread1. Can I say this itself is my thread object?
Yes.
Yeah,
yes.
I'm creating two threads. Okay. Now, so do I need to override the run method or not needed?
Yes.
We need to override the run method, correct? Because whenever you are overriding the run method, the control will come here. If not, it will go to the default run method of thread class. You see, whenever you are writing a thread, why are you writing a thread? You want to perform some operation multiple times. Where you can write that code in run method. Can someone tell me what is the definition of a thread?
Execution of a task.
Okay.
It is a lightweight process.
Depending.
Yeah.
A program.
Okay. Anything else? Let me tell you the definition of a thread is nothing but an independent path of execution within a program. Does anyone know how to visualize a thread? Okay, so this is a definition of a thread, guys. Let me pull this one.
Process.
Yeah, parallel processing. All these are fine. Now I am asking you, can you debug a thread?
Yeah, we can.
How?
Yes, by through visualization.
By
Visualization, thread visualization, can do.
Okay, but in this Eclipse, I want to do with a standalone Java program.
Yes,
let me show you.
Debugging mode.
Yeah, okay. Let me show you that. Okay. So thread is nothing but a independent path of execution within a program. This is a definition of a thread. Now, where the thread flow of execution starts? From run method, right? Now, in the run method, what I am doing is, I am calling singleton.getInstance method. Singleton.getInstance, this line. In the run method. Okay, done. Now let me run the program. Now, in order to start the thread, I will do t.start and then t1, t2.start. Done. So now let us keep a debugger in this method. Let me write sys out. How can I know what is the current thread name?
We'll give the name.
Okay, now in run method, I want to write what is the current execution method thread name. If I want to see correctly, can you guys tell me? I will run the program. Can you guys tell me at any point of time which thread is executing a run method? Can you guess it? That means, can I say that only first T2 will execute and then T1 will execute? Can I guess
No,
that?
no, we cannot
Okay.
guess.
Now, I want to know at any point of time, I want to know which thread is executing this run method. How can I do?
So you didn't change the name for T1 to T2 for the second.
Yeah. Okay, fine. At any point of time, I just wanted to know, see, here I created two threads. Two threads will execute this run method. Now I want to know whenever that corresponding thread is executing, I want to know which thread is executing.
There is a method.
Some get thread, current thread dot get name.
There is a current thread dot get name. This will give you the current execution thread. Okay. Now let me debug this one. Debug as Java application. Let me keep a debugger here as well. So in the debug window, let us open it in a debug mode. This is very important. Please pay attention. Now, main method is also a thread in Java. Look at here. So whenever you're debugging, go to the debug section. You can see on my left side, you can see thread main. So that means it's a thread. Now, what is the definition I told? Thread definition. Thread is nothing but an independent path of execution. That means, now let us see. I have set the name. So look at here, till line number 11, no thread is created. Now, whenever you say start method, this start method will create an independent path of execution. Now, currently you are only one path is there. Now, let us run the program. F6. Do you see one more path has created? Yes or no?
Yes.
No. Can I say that the definition is holding true? Thread is nothing but an independent path of execution. See, whenever I say start method, now who is responsible to create a independent path of execution? The start method. It is present in the thread class. So since it is I'm calling, see, can I call the parent class method using a child class object? Yes.
Yes.
Now T1.start. So whenever I say start method, the start method is responsible to create an independent path. Look at here. Currently my main method is in line number 13. Now thread, see, what is the name of the thread? Thread 1. See, look at here, thread 1. Where it is? It is executing line number 19. Now let's go back to main method. Again, do F6. Look at here. T2.start means, can I say one more independent path of execution is started? Yes or no? How many executions are there in this program now?
Yeah,
Three.
One is main, one is thread 1, one is thread 2. Correct? Now, where this thread 1 and thread 2 are currently executing? Line number 19. Correct? Now, in line number 19, what am I doing? I'm going to the get instance method. Let's keep a debugger in the get instance method. Okay. Now I will do F6 in thread 1. I have clicked on this one and do F6. Okay, done. What is the value? Currently null. Correct? Now, when I go to the thread 2, can I say that multiple threads can execute at a same point of time, even millisecond also?
Yes.
Right. If I am running a program, can I understand that? No. That's the reason I'm debugging. Now I'm taking a scenario where first I went to the thread 1 and currently thread 1 is in line number 25. Now I'm going to, at the same time, I'm going to thread 2. Now I will click on this one. Now can I say S2, what is the value of S6 in this one? Null. What is the value of S in this one?
Null.
That means, can I say that both the threads are looking at the object S as null, correct? Now, can I say both the threads will go into this line?
Yes.
At a time, correct? Then whenever it is going S equal to new singleton, how many objects will be created? One object will be created by thread 1. One object will be created by thread 2, correct?
Yes.
That means, can I say that I am creating 2 objects for singleton class?
Two objects.
Yeah.
Am I breaking?
Breaking.
Yeah. So now, in order to fix it, now you guys tell me from the core Java, so what does it mean when one method is executing, one thread is executing, I should not allow other thread to execute that, correct?
Yes.
So what do I have to do in order to make
synchronize?
that?
Synchronize.
Yeah. So we need to use a keyword called synchronized, correct? Let's
Yes.
make this method as a synchronized. Now, do you guys have seen how to visualize a thread, correct? How to debug a thread?
Yes.
Yeah. So that is very important, guys. As a Java developer, you need to have the multi-threading knowledge. See, T1 dot start, T2 dot start. Currently T1 is, now let us look at here. Now T1 is in line number 19, T2 is also line number 19. Now for thread 1, I will go to line number 19, done. See, is it executing a synchronized block?
Yes.
Yes.
Now,
Yes.
but do you see, whenever you might have read some concept saying that whenever a thread is executing a synchronized method, it will acquire the lock, correct?
Yeah.
What does it mean? On the same object, any other thread cannot execute any other synchronized method, correct?
Right.
So now, if whenever you say, look at here, whenever it is currently executing get instance method, do you see the lock symbol here?
Yes.
Yeah, lock.
That
Yeah.
means it has acquired the lock. What kind of a lock it has acquired? Is it a class lock or object lock?
It should be class, I think.
Glass.
Why it is class?
Static.
Yeah, because it's a static. Static belongs to a class. If I remove the instance static, then it becomes an object lock, correct? Now from line number 19, I'll go to the thread 2. Am I using the same class here and get instance method? But
Right.
on top of this class, can I say that already lock is present?
Yes.
Yes.
Now, if I say F12, can this thread will execute or will it go to the wait mode?
Wait mode.
Wait mode.
Let's look at here. Now, if I click on this one, see, do you guys see that thread went into the stepping mode?
Yes.
Yeah.
That means it is waiting for the lock to be released by other thread. Okay.
Okay.
Now let's go to this line. Now that means how many, see, currently S is null, correct? Earlier, if you look at, both the threads started executing this method because there is no synchronized keyword. And both the threads will create an object. Now, if you look at, now what will happen? This first thread will create an object. Yes?
Yes.
Now SA object is created. Now, if I do, now currently, see, other thread started executing. Look at guys, correct? See, in this one, I have just completed the thread. The earlier thread 2 went into the stepping mode and it has come back to the execution, correct? Because the lock is released. So when it is coming back to the execution, do you guys see what is the value of S?
Yeah.
It is no longer
Yes,
null,
object
correct?
is-
Now, can I say that, am I creating multiple objects now?
No.
No.
So can I say that I have broken the pattern and I have fixed the pattern by writing the
Yes.
synchronized keyword?
That's correct.
Yes.
That's correct.
Yes.
Yeah. Do you guys understand, everyone?
Yeah,
Yes.
clear.
Yeah, it is little hard to explain, guys, but I hope I have done good.
Yeah, better job, sir.
Okay. Now, the problem with this code is, for example, in this synchronization method, I have 100 lines of code. Sometimes, so whenever I say synchronized, entire method will be logged. But I want to do the synchronization of some part of the code, not the entire method. Then what should I do?
You have to do it at object creation
Different
level.
blocks you have to write.
You
Yeah,
have
we
Object-
need to go for a
block.
synchronized block that rather than
Objection.
synchronized method, correct? How can I write a synchronized block?
Synchronized.
Keyword
and
synchronized.
Yeah,
synchronized.
yeah. And then class name. Or you can give the reference. Now in this block, let me write like this. Okay, done. Now let us see here. Now let me write sysout statement. Okay, done.
But method is already synchronized.
I'm removing. I will be removing. Yeah. Okay, let's debug it again. Now let us see, 2 threads are created. Now first thread, let us go to the get instance method and keep the debugger. See, do you guys see, since I removed the synchronized, one thread is executing. Do you see any lock symbol?
No.
No. Now let's go to the second thread. Is it executing?
Yeah.
Look at here. Say till 27 line number, both the threads will execute. Correct?
Right.
Yeah. Now, so now assume that let us assume that first thread created this one. Now second thread is also at this point of time. Okay. Now, what the value of S? Null, correct?
Yes.
Okay. Now, if one thread is entering this one, okay, currently at this point of time. What happened?
Cannot enter the synchronize
Okay, let me keep
null
class name.
class name.
Yeah, let's debug it again. See, 2 threads have created. Whoever is not speaking, please go on mute. Yeah. So first thread is started executing. Now let's go to the second thread. It has also started executing. Done. So it is in this right place. Okay. Now, what is the value of S? Both the threads? Null. Correct? Now, let us enter this block. Okay. Now, currently, look at here. S value is null. The thread has acquired the lock. Correct?
Yes, yes.
Okay. Now, so now when can the other thread will execute?
No, it will not execute.
It will not execute, right? Now let's see here. So it has okay. Fine. Okay. Now it is returning. Okay. Now, but do you see the code is entering? Yes. Now, so now assume that both the threads are at this line at the same point of time. Whenever you're writing a synchronized block, now can I say that even without a synchronized method, with a synchronized block also, am I able to create multiple objects? No. But the thing is, if the time duration is also same, then I just wanted to tell that. See here. So you are making, so when should I enter the synchronized block first of all?
Block if S is null only.
Yeah. So in the earlier scenario, both the objects are able to come to this line, correct? Right. Whenever this condition is executed, both the objects are able to look at this line, correct?
Yes.
So then there may be a possibility. That means yeah. So then there may be a possibility that both the threads will try to access at a time. Then there may be a possibility of creating a new object. Then to overcome that one, what do we do? So outside of the synchronized block, we add a null check, and inside the synchronized block, we add a null check. This is called as a double checked locking. Why? Because when one thread is executing, second thread is no longer null. So it will not even enter the synchronized block. So in order to avoid that, what you call situation, so we add a check outside of a synchronized block and we add a check inside the synchronization block. So that check is called as a double checked locking. So whenever you are working with a multi, don't worry, I have to just write a written statement. We'll write that, not a problem. So whenever we are using a multi-threading, so if you are not writing a synchronized keyword, then the problem is multiple thread can execute and then it will give the multiple objects. In order to overcome that, we went for a synchronized keyword. If you are writing a synchronized keyword for a get instance method, then there itself the problem will be solved. Only one thread will execute only once. But the problem is, if you are making the method as a synchronized, entire method will be logged per object. But inside a method, there are some lines of code which can be executed like for every thread. Only some part of the code should not be executed. So in order to make that, we go for a synchronized block. And I have to allow the thread only when the instance is null only. When the instance is not null for the second thread, I should not even give the access to that. So that's the reason I'm writing this outside check. This kind of writing the check is called as double checked locking. So this is another way that we can break the singleton design pattern and we can fix it. So there are different ways. There are some other ways also like reflection and cloning. We'll be discussing the reflection and cloning in the upcoming class.
Karthik, one question.
Yeah.
Let's say we wrote the second if condition, right? So that we could not replicate that failed case for that, right? Is it because it is difficult to replicate, and if we don't write that, both the threads will try to acquire the lock at the same time, and it results in some deadlock situation.
Yes, yeah.
So, which is a, rare case, but it can happen.
Yes, it can happen. Yes. So when you are trying to debug it, right, that kind of scenario creation is not possible. But I hope you understand what I'm trying to say, right?
I got that. My second question is, let's say we are writing synchronized at method level. In that case, obviously,
the method access will not be given.
Will not be given. That is a trade-off for that. I agree that. But in that case, we don't need to bother about writing two if conditions, right? In that case.
Yeah. No, only one is fine. You don't see.
One is fine. One is fine. So that will work with flawless. Without any problem, right?
Yes.
Oh, good. Thanks.
The thing is, inside a method, like here, I have written only 5 to 6 lines of code. But in the real-time project, you might write a method different,
I got that. There can be thousands of lines of code which require, which might be used for some other purpose, very crucial purpose, which doesn't require any, multi-threading, locking and all. In that case, definitely we should go for blocking. I just wanted to understand this. A double check is not required if you synchronize at method level. Is that the correct statement?
Yes, that's right.
Okay, thanks.
And one example in Java, which class is following the singleton design pattern? The answer is runtime. There is a class called runtime. Let's click on this one. So do you guys see runtime.class? So I have opened the .class file in Eclipse. Okay. Now see, runtime is a class. In which package it is present? Java.lang package. Now, how can I say that runtime? See, since it is a class, can I create an object? Let us go and create. Runtime r equal to new runtime. Am I getting a compilation error? Yes. Let us see what is the compilation error. Look at here. The constructor runtime is not visible. What does it mean?
That means
when the constructor will not be visible?
Private.
We're not able to create an object.
Private.
Yeah, it's a private. So now let us see. See, it's a private constructor. Now, but I want to get an object. How can I get? Do you see one method called get runtime? Yes. What it is returning? It is returning the instance of runtime. Now, get runtime. Runtime dot, instead of get instance, what is the method name? Get runtime. So that means there is no guarantee that you have to keep a get instance method name. You can write any name, correct? Now, can I say that this will give me the runtime object? Yes. Now, how many times it will create? Only once, correct? It is giving current runtime. And they are creating it class level, because this class is loaded during the class load time itself. Okay. And it's a private. No one can access directly the current runtime, correct? It's a private variable. Now, this is the example of, so in Java, in JDK, the people will call in Java or in JDK, which class is following the singleton design pattern? The answer for that question is runtime. Runtime is a class in Java which follows a singleton design pattern.
So just, anyway, we came to runtime class. Did they use this double checking for serialization also? Or?
No, when you are doing the lazy initialization, then only you can go for a double check, right? So they are doing the eager initialization. What is the need for that?
Okay. And then this, what is that other one? Reflection safe, they did it? No. Serialization safe.
I think the class itself is not implementing a serialization interface, right? No one can do the serialization, right?
Okay, fine. Okay.
Yeah. See, I see. Whenever I'm explaining in the interview purpose, they might ask you, I can override, I can break this pattern. See, for example, you have written this code without implements. Then what they will say, I will implement this serializable, then I can break using a deserialization.
Yeah,
that is the question they will ask.
Just because it is you showed something already existing from Java core. I wanted to check whether they implemented.
No, they did not. because they are
And,
not providing.
I
easy
remember
relationship.
something like for calendar also we'll use get instance.
Yes.
Gregorian
Yes.
calendar dot something like that.
Yes. Those are the different classes. Not this one. Java.sql calendar, I think.
No, this one only. Regular calendar only. They'll use the calendar dot get instance there.
Yeah, they will use the get instance, but create calendar. Yeah, it's a static method. Yes. Yeah. Yes. Like that is one more example. This is a straightforward example.
Okay, thanks. Any idea what is for that used the runtime class?
It is during the loading of the class they will be using this one. Whenever you are using a garbage collection. So this method, there is a method called GC. See, if you want to call this garbage collection, that is present in the runtime class.
Okay.
See, you don't call the garbage collection automatically. JDK will call it, right? So in order to call that, runtime.getRuntime.gc, then operating system will run the garbage collection. Unwanted objects will be removed.
Yeah,
that
I
is
saw
the use of the runtime.
people were using system.gc. Maybe this is also automatic.
System.gc internally will call runtime GC only.
Okay.
System.gc. Correct. Now, system is a class and GC is a method. Now you go inside this. What they are doing? Runtime.getRuntimeGC. Same code.
Okay.
Different people will use different one. Even if I call the system.gc internally, runtime.runtime.gc, both are same. Okay. So if no question, yeah.
Is it runtime is not calling it the class loading, like calling the method, or
no? It's class loading itself. It's a static variable, right?
Right. So is it going to call main method of the class or only for the GC related, garbage collection related?
So generally, do you write a main method in every Java program?
Yes. Not every.
Not see here. Why the Java creators will write? They don't want to write run a program, right? You want to run a program, then you will write. They want to use this class objects methods in something else. They don't write a main method, right? They should not. If they run a main method, I can run that program, right? Yeah.
Okay.
So that's all for today, guys. And today will be the last demo class. If you guys are interested, you can enroll for the course, and whoever is completed the enrollment, they will be added to the WhatsApp group, and the new Zoom link will be given to them over the weekend. And you might have received an email from the Ashok IT, right? Let me show you guys on the enrollment. Just a minute. Let me stop sharing it and pull up the email. Just give me a minute, guys. I'm just pulling up the email from the Ashok IT.
So other two, breaking methods will be, mechanisms can be told in the next class. We covered serialization reflection, right?
Yeah. We'll be discussing in upcoming class because the time is 1 hour, so we are on top of time.
Okay.
So this kind of email you might have received, Java design patterns 5000, and these are the previous links, guys. Let me copy this. And so this is an email that you will be receiving from the Ashok IT again today. So in that, see, previous 2 classes are there. Today, whatever the email that you are going to receive, you will be having the 3rd class as well. And if you would like to do the enrollment, you can do the enrollment on this bank details, or you can pay the fee on this Google Pay number. After paying, you just take the screenshot and send it to this email ID, and you can mention name, contact number, timing is 9 a.m. to 10 a.m., payment screenshot. And at the same time, in the morning, I'm also teaching data structures and algorithms. In the data structures and algorithms, we are going to see all the linked collections, internal collections, custom collections, linked list, stack, queue, trees, graph, sorting programs, searching programs, pattern matching, matrix also, like single array, double array, and all. That is nothing but a matrix. So all of those things we are going to see. And it's we are in the live class, we are going to solve some of the HackerRank programs as well. So if you would like to know, like it is just completed, we just completed around 9 to 10 classes. And if the demo classes are completed, the fee for that course is 7,000 for live classes. If you would like to have the videos, then 10,000 rupees for the videos. So all the demo classes links are provided here in the email that you are going to receive, right? Session 1, session 2, session 3, session 4, session 5. So all these demo classes, you can watch it. And if you are interested to join for that, you can pay the amount and then you can join. Any questions, anyone?
Sir, actually, I want to ask you, any other batch you had taken for multi-threading, we can say?
No.
Okay. Means core Java, you might have covered a multi-threading concept.
Yes.
Okay. Because I'm weak in multi-threading, so I was.
Okay, fine. So I have already covered recently. I have completed in the month of January. I completed the core Java. So in that I have covered this multi-threading.
Sir, have you covered that multi-threading concept with respect to like experience person?
Yes. I have taken one example of salary calculation, and with the executive framework we have covered.
Okay, thank you, sir.
Yeah. Sir, I told you, I have not completed the microservices. So should I continue or should I join in the next?
It's up to you. You can join. See, by the time we reach microservices, it takes around 25 to 30 days. Okay. By the time if your microservice you will be able to learn microservice, then it's good to join. Yeah, you have time.
Right. 25 days, na sir? 25 to 30 days, right? Okay,
yes.
Then they will complete, no problem. Yeah, sure.
Okay.
Okay.
Any other questions, anyone? So yesterday, some people are saying that they haven't received an email. Now, I hope everyone has received an email.
Yeah, just for the benefit of people who did not receive email, just paste that payments stuff in the chat, sir. I mean, I received it, but others were benefit.
Yeah.
Maybe that email and the payment stuff, enrollment process, that thing.
Yeah, I'm putting in the chat as well. Yes, thanks. So in the data structures, what we do, guys, we will solve the HackerRank questions in the live class itself. So some of my previous students are part of data structures. They can talk about if they are present in this course. Okay, fine. I think no one is there. Okay, that's all, guys, for today. So if you are interested, please do the enrollment as soon as possible. Okay, and from Monday, we'll continue with the rest of the classes. And all the enrolled candidates will be added to the WhatsApp group, and they'll be sending the new Zoom link to your email address and then the mobile number. Yeah. Thank you, guys. Thanks for joining. Have a nice day.
Thank you, sir.
Yeah, thank you.